and welcome to Weather Geeks. I'm Dr. Marshall Shepard from the University of Georgia, and today on Weather Geeks, we're talking about something near and dear to all weather geeks: weather modeling, the GFS, the Euro model, how they're getting better, who has the best model. All these things we're going to be talking about today with Dr. Richard Rood. I know him as Ricky Rood. He's actually a former colleague of mine at NASA Goddard. He's a professor in the climate and space sciences at the University of Michigan. He's also serving on various panels that are advising NOAA and the National Weather Service on their modeling capacity. So he knows the stuff on models. Thank you for joining us.
You're welcome. Thanks for asking.
And let's get right into this, because models are really at the underpinning of many of our weather forecasting and what many people are using in their forecasts, whether they're looking at their apps or getting information from the National Weather Service. Can you just briefly talk about the role of modeling in weather forecasting?
Well, models are ubiquitous in our society at this point.
Sure.
You know, they tell us how airplanes land,
right,
and things like that. So they provide the primary guidance. You know, they take the physical equations and they make the mathematical formulation of them. They provide guidance for forecasters to then use.
Right, and so I think people don't realize that these models are solving basic equations that are describing this fluid above us, the atmosphere, and then making sort of deterministic, in some cases, forecasts out 1 day, 3 days, 5 days, and so on.
Well, not just the fluids, but the chemistry and the physics and everything.
Exactly.
Yes.
Now, let's pivot to some big news that came out in the last few months or so, maybe even weeks, that NOAA, the National Weather Service, is bringing out in the next few years a new model, a new GFS, if you will. We're getting rid of the old GFS. Talk to us a little bit about this new GFS and how it's dramatically different from the old GFS.
Well, so the new GFS is part of a program called the Next Generation Global Prediction System, which is a project. And the beginning of that project, they did the selection of the dynamical core, which is sort of the skeleton or the framework, which helps determine how the fluids are calculated, as well as how well it performs on the computer.
Right.
And so they did something of a competition. They did an evidence-based, open, public evaluation in order to
You mean we had like a
core.
space race for the weather models in the same way that we're having these races of private companies to space? We had different groups competing for weather models?
In a way, we had 2 rounds of competition.
Is that
the
right?
first round we had 5 or 6 dynamical cores, and they were down selected to 2. And in the last year and a half about, these 2 cores have gone through a battery of tests in order to determine both their computational and their physical science performance.
Now let's talk about this, and I want to get a little, and shout out to Dr. Louis Uccellini, who's a friend of Weather Geeks. We have on all of the time, but there have been papers and press articles that come out showing where the GFS model ranks compared to others, and we're going to talk about why the European model has ranked near the top. But obviously there were some reasons that the GFS needed to evolve. Some people, and there were critics out there that didn't agree with the choice that NOAA made. Do you agree, and why?
Well, so the choice that was made was the dynamical core. That's a finite volume, non-hydrostatic dynamical core.
Yeah.
It's a core that is associated largely with Geophysical Fluid Dynamics Lab, Princeton University, but actually has a history back to NASA when we were there.
Sure.
I would say from the tests, I think it was the right choice, and it's a very, very good choice. Performance-wise, in terms of its scientific, its forecast performance, if you look at the tests we've already released, out of the box, untuned, it's comparable to the current GFS.
Right, right.
The other big issue with it is it's a computationally just a fantastically fast model, and can scale up you might have seen some of these pictures from NASA of the very high resolution. That's the same dynamical core, and in some of those applications, it's scaled up to 100,000 processors.
Oh, wow. Yeah. So yeah, that's part of our ability to improve our model forecasting capability is really often tied to performance and computing.
Yes.
And after Sandy, the National Weather Service received funding from Congress to up their game, and I think we're seeing some of the results.
Well,
of some of that.
all of this, the first rounds of tests and this, really follow from the Sandy supplemental.
Absolutely. So,
Yes.
Out of something very horrific, came some progress.
Yes.
When can we expect, this is not around the corner, it's going to take years of development, is that right?
Well, so the dynamical core is just the first decision to be made here, and it's one that went through this process. It took a long time. There are a lot of other decisions that need to be made, many of which are just as important.
Yeah.
The whole implementation plan, we're looking, 2018, 2019 for the next generation model.
Right.
But there are some decisions, there are some data simulation, some physics roadmaps. And one of the most important things now, I think, is to start to look at the design and the architecture of the next system, because our ambitions for it are much broader than for the old GFS.
Right.
And we have had really fantastic development of something called the NOAA Environmental Modeling System framework, which I think is equally as important to the dynamical core selection, that we need to really start working in that environment.
Now, this is going to be a tough question, but you're an expert in this, and you can't maybe give the answer I want to give. But for our Weather Geeks viewers out there, what can you tell them that this new GFS will deliver that is meaningful to them in terms of time scale, resolution? What improved for what is perceptible to them?
Well, I think that one of the things that will allow us to run at much higher resolution. The tests we did were already at 11 kilometers, and it was working really quite well. So I think we'll be able to get down to higher resolutions.
So what this higher resolution? Let me make sure our Weather Geeks folks know that you've got a digital camera. You've got a camera with certain megapixels. The more megapixels you have, the finer the resolution of that picture. The finer the resolution of our models, the better we can represent some of these smaller scale processes in weather in the atmosphere, maybe a convective thunderstorm.
That's right, and the tests that we did actually also included the ability to look at nested grids down to 3 kilometer resolution over the United States. So one big aspect of it is the resolution, but I think the real benefit is ultimately going to come in the new physics packages, and I think that with the non-hydrostatic physics and things like that, it'll be able to support a much more robust physics package with better moist physics and things like that.
And that basically translates to better prediction of some of the types of flooding and thunderstorm systems that we often see affecting the nation. Now, when we come back, timely forecast and accurate forecasts are critical to the nation. I want to talk more about what are some of the other steps we need to take to improve future weather models. But next, our Geek of the Week.
This week's Geek of the Week is NBC Connecticut meteorologist Ryan Hanrahan. Ryan loves tornadoes, hail, and thunderstorms, but his most favorite weather is a snowstorm, not just because of the weather, of course, but because he likes to ski. It also makes sense that his favorite meteorological term is dendritic growth zone. Congratulations, Ryan Hanrahan, our Geek of the Week!
And we're back on Weather Geeks, and we're talking weather models today, and with one of the nation and world's top experts on modeling, a former NASA scientist, currently a professor at the University of Michigan, and one of the top advisors to NOAA on weather modeling. Now, as we're taping this, we're seeing one of the most tragic flooding events and natural disasters in recent years in Louisiana. And one of the things that I've often said is that we need a modeling system that captures sort of the Earth system, what's falling from the sky, soil moisture, all the things that can lead to some of these sort of catastrophic weather events. What would you say about the need for Earth system modeling?
Well, if we go back to what we were talking about before, this idea of the better GFS and what people might see, one of the big advantages of the new modeling systems we're looking forward is that they will have the ability to couple and to have the Earth system modeling aspects of them.
So it's not just the atmosphere.
It's not just the atmosphere. And if you look at, say, the ECMWF strategic plan and what they talk about for the next 10 years, all of that, even on their 2-week time scale, they're talking about the necessity for coupled interactive models, the ability to have the ocean, the ability to have the land interacting with it. Ultimately, it's going to be the sea ice and the big changes that are going on up in the Arctic.
Yeah, we're seeing this big Arctic cyclone right now moving over already tenuous sea ice.
Right, we're seeing very interesting things like that, and they're at some level the models haven't seen these things before.
Exactly.
We're retraining models at some level.
Now, speaking of mine, we're going to talk in the last block after the commercial about the King of the Hill model of Euro. We'll get into some interesting discussion there. I want to talk a little bit about this pivot towards private companies like Panasonic and others getting into the modeling game. What are your thoughts on that? And then I also want to get your thoughts on whether should have a community approach.
So if I look at what I know about the Panasonic, which is through the press and actually through your show, it reminded me of a couple things. You probably knew Don Anderson
Sure,
at NASA.
Sure.
And in 2008, I actually wrote him sort of an analysis and a position paper on modeling outside of the government. And the interesting thing about that is our conclusions were that it's quite feasible to do it. And the scale of what I see at the Panasonic effort is comparable to what I think we were talking about. So feasibility-wise, I think it's good. What interested me was that they were talking about competition so much. And it's not clear to me that sort of the business of competition is really the way to do science in the long term, because competition tends to be sort of short-term gain.
This is an interesting thought.
And I think the investment in real Earth system modeling is looking at long-term gain that's going to take a long time. The other thing that struck me in that was, the only sort of metrics that they thought about, were things like anomaly correlation and the atmospheric ones, and that's not our system.
That's right, that's just the atmosphere.
And so if you're really looking at these problems of, the 30-day forecasts, which we're now talking about for a variety of reasons, that has to have the coupled system in order to get there.
Absolutely. There's so much sort of regulation and memory in other parts of the system that affect the atmosphere. So
Exactly.
I think your point is interesting about the role of competition, and that's going to be a topic that we're going to continue to have here on Weather Geeks as well with some of our future guests. Now, when we come back, get ready, tweet everybody out there to get on Weather Geeks. We're going to talk about the European model, why it's been the leader, and what we can do to catch up if we've not already caught up. Next on Weather Geeks. Back on Weather Geeks, and one of the things I often see in Twitter is this discussion about the Euro model. The Euro model is the best model, the GFS. Look, they're both world-class models. I mean, the differences aren't vast the way you see some of the discussions in Twitter on this, but certainly the analysis does show that the European model has outperformed on average compared to the GFS model. Can you talk a little bit about, from your knowledge as an expert, on what they're doing that we're not, that makes them a little bit better?
So it's been true pretty much since I've been in this field that the Europeans have been setting the standard. And part of my job at NASA was actually working with then Tony Hollingsworth and David Burridge to understand their approach to modeling and the like. And what's true then is still true now, which is, as an organization, they are very much focused on their single product, and that they feel that they have to be the best in order to sort of maintain their funding strategy and their position. So they really take a much different approach to modeling. The big barriers in modeling and making modeling better in the U.S. are issues of management, issues of thinking about the system as a whole. And if you look at the European Center's approach to strategy, just looking at the document, it integrates the organization from top to bottom. They don't talk about, we'll build this system, we'll build that system. They have a very narrow range of sort of forecast goals. And then they talk about how are they going to get to those goals. And what's really interesting to me is sort of at the beginning of their new strategic plan, which I've been given a courtesy copy of, they talk about the people. They talk about the necessity to be able to recruit the right people. And then so there are many aspects of the way they approach the problem, the way they manage the problem that's important.
And that's one of the things I've often said. It's just, in some ways, almost an apples and oranges comparison, because NOAA has to launch satellites, they have Doppler and polarimetric radar, National Weather Service Office. So they've got it's a management challenge. They are using a different kind of data assimilation approach as well.
When it gets really down to what's making the difference, it's their use of data. It's the data assimilation approach. And it's their really scientific approach to the observing system and the ability to use that information to make really good initial conditions for the forecast. So They also put a lot of attention in their assimilation and their modeling to consistency. There's a lot of physical consistency in what they do.
Right.
So it is definitively superior treatment of data in the assimilation system and has been for quite some time.
And let me make sure you guys understand what we talk about with this assimilation. You know, in the old days, we started a model with the atmospheric sounding of weather balloon, and we just ran the equations. With assimilation systems, we can update the data with observations from satellites and other things, and they have a four-dimensional and a more, sort of, in some ways, elegant way of doing that, although maybe that's arguable. Now, in this last minute, Ricky, we talked about resolution and computing, but is there anything else that can move the needle on modeling for the next generation, the next 25, 35 years?
Well, I think the treatment of physics, the better treatment of physics, I would personally give that higher attention than resolution, though the two are, linked to each other, and the physics changes as resolution, better assimilation. And I really think that if we're going to do this problem of the 2-week, high-impact weather events and things like that, we are going to have to go to coupled modeling, and I think that's going to be a big challenge, especially in the U.S., to get the resources together to do it.
Right. Unfortunately, that's where we have to end it. This is a topic that's always popular to our guests. I want to thank you for joining us on Weather Geeks. And remember, we're always here on the Weather Channel, 12 noon on Sundays. You can also find us on Twitter, WX Geeks, TWC, and we also have a Facebook page. We'll see you next week on Weather Geeks. Here you go.